Name, I'm Dietmar Fuchs. I'm working for the company ColorLogic. We are a German-based company, founded 2002, developing high-end color management solution. That means we create profile solution, ICC profile solutions like Copra Ray Profiler that create ICC profiles. And the ICC allows as well different profile classes. One of those profile classes are device links. And device links are specific class that allows to keep, for example, zeros, as you explained, from going from RGB to CMYK, or more important, CMYK to CMYK, because there is a lot that can go wrong in CMYK to CMYK conversion. I will come to that when I do my presentation here. The other thing is, of course, you need to apply profiles and device link profiles somehow, and therefore we have a tool which is called a color server that does a PDF to PDF conversion with device links and ICC profiles. Other tools are what we call the profile tagger to figure out if a certain CMYK value fits to a certain output intent. Now, if you, for example, have a newspaper print and you have a CMYK image in there that has a 330% of ink in there, you will have a big problem when you print that file. Therefore, you have to check those things as well. So my topic here is to explain something about color in the world of PDFX for printing, for example, but not only for printing. We talked a lot about those things, but for example, PDFX allows as well to have an RGB output intent. That's all possible. So we could have that as well. Thinking on a PDF file, there is a lot of color spaces that are supported for all kinds of objects. We have, for printing, obviously, we have images, vectors, and text. We have a lot of different color spaces, and if you look at that table that I have in here, depending if a color object has an ICC embedded, it is called ICC-based, gray, RGB, CMYK, for example, or just device gray or device RGB, device CMYK, or it could be a spot color, and then it's a device N. So these are not all color spaces, obviously, but the most important that I wanted to mention here. And with all these possibilities and setting up a PDF with colors, there is a considerable potential for errors if that is done wrong. And I would like to give you some hints during my presentation what you could do to improve, especially printing, but I think it's the same thing for RGB output as well. A simple example of a document, a PDF file, for example, we talked about, and we heard that in various presentations from Stefan and from Peter as well, there is an output intent, so that's something which sounds as a different color space. In fact, it is basically only the idea of how this document that I'm creating is intended to be printed or output in general. So that means if you create a PDF, the output intent tells the next one that will get that PDF, a printer or service provider, knows, okay, I should render it according to that output intent. And that output intent is basically an ICC profile. Could be an RGB, could be CMYK. So that means, for example, in my example here, where I have device CMYK vector and device CMYK images, and the output intent is a CMYK output color space, as in this example, offset print on coated paper, like ISO-coated, FOGA 39 or swap or whatever. Those colors that are a device CMYK in my document ought to be that output intent. So I don't have to give additional information. If I say, okay, that's an output intent, and I have this device CMYK colors in there, as in this example, they ought to be in that output intent. Whereas, for example, an ICC-based RGB should be converted to that output intent to be rendered correctly. So looking a little bit more into the color world, so we are looking now into the RGB world, and what I've done here is basically to put one RGB image and render it without changing the RGB values by simply just assigning different profiles to that image. You'll see all different kind of colors that you come in here. And I'm doing this to make you see that basically the RGB values don't give you any clue about the color. So the color is what we see in our eye, and that is displayed or described with a LAB value. That's something that a spectrophotometer can measure, for example, or that we are then transferring to our eye. And only with the profile that gives us the RGB connection to the LAB, this gives a color meaning to our eyes. And depending now, if I assign the wrong profile, so I assign 5 profiles to the same image, and the only one which is true is the ECI RGB version 2 one that we see there, because I know from the creators of those files, from this Roman 16 test images, that they were created in that color space. But if I'm assigning the wrong profile to it, I get the wrong color. And I'm doing that because very often people forget to assign the profile to the image and then provide it to somebody else. And somebody else does not know anything what he's doing with that. So he probably assigns it with the wrong profile. A very common wrong profile for these things is sRGB. Yeah? So if I don't know something about it, I probably assume sRGB. And that's what you said. And this will happen. This is my nice image. It should look like the one on the bottom. sRGB, well, the lady looks a little bit pale. The colors are more orange, very pale basically. The contrast is different, completely different. So I get a wrong color output. And the only thing which I have forgotten is to assign the profile and to put it into the PDF. Probably that could be the reason for that. And what's happening basically in an ICC color management workflow and how that can be much improved is what I call the ICC color management road. And if I have that image now, if I want to display it to a screen, or I want to print it to a printer, there are always 2 profiles involved. The source profile, as we've seen here, an sRGB profile, which is assigned to that image. This describes how those colors shall be seen, which means this, in the profile, we are doing basically a connection to the LAB color space, which is our visual color space. And now we have, so to say, a meaning from those RGB values, how we see it, how we perceive the colors. We could even plot in a 3-dimensional LAB color space how those colors would be rendered as a cloud of points, for example, here. And you obviously see that this red image only uses the red part of this LAB color space. We'll need that image later on, so please remember. So that's the first part, the first step of the conversion that's happening in ICC world, conversion to the LAB. And the next step that we want to do is we use the second profile. For example, if I'm going to a printer, I need a printer profile that describes my printer, basically. And then I'm converting with that second profile from the LAB to my printer, and then I get a faithful reproduction without this fancy colors that we have seen at the beginning, that we have seen when we showed the 5 images. So again, this image that I have here, if there is no profile embedded to it, or my printer is not profiled, you will have no clue how it will look. And if I have to print it on my nice photo printer without color management, I end up very likely with this. So this is not a fake image. I just take a profile from an absent printer in this example and didn't apply color management. I just assigned it, that profile, to my RGB values without changing the RGB values, and then you get this very wrong color. However, if you use the same profile and you apply color management correctly, meaning you are using a rendering intent that convert the RGB values to that printer, you will get a faithful reproduction of that image, and it would look nice. The same happens if you apply, or if you send those files to your clients without embedding that profile to the image. Your clients have no clue what to do with that and will probably make the wrong assumptions. Another thing is, if you do everything fine and you assign your image and you look at the screen and say this is the color, but unfortunately your screen is not calibrated, and then it's obviously as well the wrong thing, because there is a profile for your monitor that describes your monitor, and the ICC road, you remember, 2 profiles from the image to your monitor, and then you would see it correctly. So calibrating your screen to have at least a good possibility to see how those colors will look like or shall look like is a very important tool. So we looked at this cloud of points from our image, now in our LRB color space. If I want to print that in a CMYK color space, typical offset on glossy paper, so high quality printing, the color space of such a color, CMYK color space like Fogra 39, iso-coated, looks like this. And and that's the color space, the gamut, describing the outer boundaries, the physical possibilities that this printer is able to print. And it's shown in LRB. The image is shown in LRB, so I can map both together. And what we see here is that there is a big chunk of that image, especially those lighter parts somewhere over there, that are much outside the printed gamut. So that means I cannot faithfully print those colors completely. And very often people think, oh well, that's an RGB to CMYK thing, but bullshit, sorry. But it's a general gamut mapping question. So it can happen as well on an RGB printer. So here I have the image displayed to CMYK. I'm now printing on my photo printer with a much larger gamut, much bigger color space than my CMYK. It would even encompass the CMYK entirely. But still, there are quite a lot of those higher saturated, very light colors outside of that RGB printer. So it can't be printed correctly. The same happens if I'm doing this on an sRGB kind of device, like a mobile or a cheap monitor, for example, where I want to render this color. So it's not only an RGB to CMYK issue, it is a question of the gamut of an image, for example, and the output device, and they could be quite diverse and need to be put together in a certain way. And that certain way, that is what Peter described before in this presentation, using rendering intents, either relative colorimetric rendering intent or perceptual rendering intent. By the way, on our homepage there's a tool called DocB's Profile Manager, with a freeware tool that can graph those things. So you can have a good idea how things are looking by just loading a profile, just loading an image, and then you see this point cloud and can compare and see how good your rendering might be, or not good your rendering might be, because colors will be outside of your printed gamut. On the CMYK part, it's getting a little bit more complex. So here again, we looked at the RGB part, now we are looking at the CMYK part. The same thing is there. If I have a CMYK that I'm printing on different kind of printers, might be an offset, might be newspaper, might be my digital printer, as in this example here, you'll have very diverse output, completely different colors. Might be the right one, might be that on the top here, the high quality offset print on coated paper on top. If I print that on gravure without converting the CMYK values, I get a very pale face of that guy. Or on the newspaper, the hair is completely, no details anymore, there's nothing in there to be seen. And on my digital printer, completely oversaturated colors. So I have to do something there. And very often people forget that a CMYK to CMYK conversion is necessary, because I want to print on my final output device. Very often the people as well forget to put a profile, assign a profile to my CMYK image, so that a printer has a chance to honor that profile, to do that conversion correctly. So that means each printing process or machine needs its targeted CMYK. There is no one-fits-all CMYK. That does not exist, especially if you look on the gray composition, which is called the separation, for example. The separation defines how the gray is set up, how much black is used, how much total area coverage, how much ink shall I put on paper. There's obviously less ink I can put on a newspaper than on a glossy paper, so I have to put that into equation. And so I have to do a CMYK to CMYK conversion. Again, if you remember the ICC color management road, I need two profiles, the source profile and the target profile, and I use the intermediate LAB color space. If I do that on a CMYK world, everything is fine in terms of the color. But there is one important thing which I'm losing, and that's the separation information. So I'm losing the information how the black was generated, and I'm losing a few other things. So I get the right color, yes, but I have a complete reseparation taking the technical terms here, I re-separate my CMYK to my final color space. Typically, if I'm just printing on my inkjet printer or proofing, that's not a problem at all. I have no problem with that. But if I'm going to be printing in a print process like offset, digital, flexo or whatever, then I have a problem doing that. And why is that? We can see it here. If you look on the top, you'll see a cyan, magenta, yellow overlapping each other. And we have a nice feature inside PDF that's called overprinting. And if you overprint those colors, you'll have something like a mixture of the color in the middle. So in the areas where those colors are intersecting, you will see that you'll have, for example, cyan, magenta overlapping, you get a blue in the middle. However, if you're doing a normal ICC conversion, normal CMYK to CMYK conversion, you get the right color, meaning you get a new cyan, a new magenta, but you'll see there is a lot of cyan and magenta used, but a little bit in the cyan there's 3% of magenta in there, and the magenta has as well some cyan. And now the overprint model wouldn't work anymore. And that's a very big break that you can have because it has a visual impact on your integrity of the file. And if you print that, obviously your client will say, oh, that's a big error, I don't want that. And you can keep those primaries clean by using so-called device link profiles that do the CMYK to CMYK conversion by keeping, for example, the black channel intact so that the black is not rendered into 4 colors at the end, or a gray is not rendered into 4 colors, for example, and that primary and secondary colors can be kept pure as well. By keeping pure, I do not mean, like in this example, saying 100% should be 100%. It could be that the 100% of my target color space is the complete wrong color because it's much too high saturated, for example. A good device link would look, for example, to figure out, okay, I use perhaps 90% of that cyan because that's much closer to my 100% in terms of colorimetric accuracy. But it is just using the primary as itself without using additional contaminating colors. And by doing that, I can keep my overprints. So that's a very important thing. The other thing that I mentioned in the beginning was the gray composition that is destroyed by using normal CMYK to CMYK conversion. If you look at this image here in the middle, that's my original, let's say. So here, this is my CMYK, a lot of slices to the color space in CMYK, and that's just the black channel of that CMYK. If I'm using a CMYK to CMYK conversion with a normal ICC way, I have a complete, that's the reseparation that I've mentioned in one slide before. I have a complete reseparation. I add some black in areas, for example here to the white area, there's now a little bit of black in there. The smoothness is completely reseparated, it's completely different, and it looks a little bit awful here in the bottom, in the top part as well. And even here on the slide, there might be to be seen some of the inhomogeneous results. Using the same thing with a device link, only changes where absolutely necessary are done. The integrity of the black is completely retained. The smoothness is much better, and you get a much better print by getting the same colorimetric accuracy, but having it much better printable. And that's the most important part. I don't lose my overprints, and I have much smoother rendition at the end point. So that's the reason why I've headlined this presentation, Handling CMYK Color Conversion Like the Professionals. That's how you should do that, basically. Stepping one step back, we've looked at RGB, we've looked at CMYK, and now why we need this as a base information is because we talked about this as well. From a PDFX point of view, there is a thing that is called normalization. And once we have an output intent that describes how a PDF shall be printed, and taking again my example image here, this time with ICC-based CMYK, ICC-based images for vectors, ICC-based RGB, what's happening in a normalization is that those profiles are taken, so the ICC-based CMYK vector or image is then converted to the output intent and shown on my display. The same happens with my RGB. So I see the file, a PDFX file, on a compatible good viewer, like Acrobat will do that perfectly. And I'll see how that will print. Yeah? So I don't see the RGB anymore. I see the RGB through the output intent, and I see how this will print. And what obviously will happen is that those CMYK parts will be normally converted with a normal ICC conversion with all those breaks that I've shown to you before. So that is a typical thing that you should be aware of, and there are obviously solutions to overcome. One of them here is a short summary. I'm not ready with my presentation, but the short summary here is that if you are a producer of a PDF, basically, you should think up front about the output device that will render your PDF. As Peter was saying, this is not always the case, that you do not know exactly what you're doing, where the PDF will be ended up at the end. But if you are having in-house documents, you know exactly, well, I'm printing this on this machine, or I'm printing this on that machine. And then you can target your output intent according to that printer. That means you should have a profile for that printer created. You should tag your image, so embedding your profiles with your images with the appropriate profiles and rendering intents. That's a very important part. We've seen what happens if I don't do that to RGB and CMYK. And a little bit of a rule, I would say, that you could think about, at least I think that's very helpful, if your output intent is RGB, because PDFX allows as well to have an output intent in RGB, then tag your CMYK data with the appropriate profile. In terms of your output intent being a CMYK, better think about using the output, your printer is a CMYK, better use the output intent, the PDFX, to assign and say, this is my output intent, and don't tag the CMYK data, so that the CMYK data stays as they are and are not converted again, to avoid those double conversion and CMYK to CMYK conversion. Unless, and there is a good solution to do CMYK to CMYK, is with workflow tools, color servers that do CMYK to CMYK with device link profiles. There are more and more tools out there in the market, including our color server that does CMYK to CMYK conversion with device links. And another thing which I don't go into detail here is, but we've seen that already in presentations from Stefan, having 11 or 12 spot colors in there can be a problem if you don't have that machine loaded with those spot colors. And very often designers like to use Pantone colors for no reason, because it's just fun or something, but it's really dangerous. Yeah, so if you are a producer, think about not using spot colors and using process colors instead. If you are on the side of a creator of a viewing application, PDF viewing application, or you're printing, use the embedded profiles that are in your files and don't discard them. Very often, as well in the printing industries, I have to say, people are discarding the profiles because they think this is an error. But that's nonsense. It's very important to honor the profiles. So if they are created correctly from newer versions of InDesign or Quark Express, the profiles are there for a reason. So please honor them and use them for previewing and for printing. That's very important, I think. And create a good profile for your output device, and that's as well an important thing, and use device links for CMYK to CMYK. There are very few links here. The Ghent Working Group gives a lot of good free information. PDFX Ready from Stefan Jägi has a very good handbook as well. I've just learned from the Fogger page there's as well. This book, How to Create PDFX Files. The Flemish Innovation Graphics Center, I think that's the name, has some very nice information about color management as well. Our homepage as well gives a few information there that might be helpful. I have, I don't know if that's something perhaps, there is a larger document that I've put as well on the Dropbox in English and German, which covers this presentation in a more textual environment, so people that want to have that should have it. It's for free, so they can
make sure that gets on along with your presentation.
Yes, yeah. So that would be nice. However, there's no free lunch, as we all know. A word of caution at the end. So using rendering intents. I'm still on time. Yeah, that's fine. transparencies, spot colors, and handheld devices. So that's something I would like to make you aware of. We talked about black point compensation, relative colorimetric rendering. So what happens here, you can even see it here. When you create your PDF documents, put in a profile into your image, and that's all fine. You typically assign that profile to your image. The image with the assigned profile ends up in your PDF, and the rendering intent, how that image shall be rendered, is as well given in the PDF. So the information, which rendering intent, is typically stored when creating the PDF file. So that means if you look at modern applications like Quark Express, InDesign, that very often the default rendering intent in those applications is relative colorimetric with black point compensation. But in PDFX, black point compensation is not supported as of today, so there is a potential of misuse there somehow. But it's very important to use black point compensation. Because if you don't do that, as in this example here, I have an image, RGB image, and just converting that to once CMYK is, I think it's ISO-coded or something in this example, but it does not play a role for the presentation here. Without black point compensation, the guy with his hair, there's no differentiation between the hair and the black background. Here on the presentation here in this room, it's probably different, but you have to trust me. On my screen here, you can see it.
We can see it a bit.
So it's really bad. So there's no differentiation there. Using relative plus black point compensation, there is this differentiation. So you need that rendering intent when you want to do an RGB to CMYK or CMYK to CMYK conversion with relative colorimetric. Unless you're going to proof print, then you should not use the black point compensation. But that's another story. So instead of using the relative rendering intent, you are very often better off using the perceptual rendering intent as your defined rendering intent, especially for converting RGB to CMYK. However, what can happen, that's probably hard to see. So in the middle here on top, that's my RGB image, and below there are 3 different variants converted basically to the same characterization data of the same printer, created with different profiles. So different profiling engines basically. So you can end up with different pleasing or not pleasing colors. So that's what Peter was mentioning about the perceived color and the pleasing color. So pleasing is very often a question of the tools that you're using, and a question of a price of a tool very often. The cheaper a profiling tool, the worse the rendering will be. So that's a general use that you can say here. So when I'm talking about profiles and rendering intents, again, I always want to say that because embedding the appropriate profiles to your PDF files is very crucial and very important. So do that, please. As the PDF creator, change the default rendering to perceptual in your design application. That's very often very helpful to do that. In case relative colorimetric shall be used, always use relative plus black point compensation, abbreviated BPC here, if you're not proofing. And in general, device links make for better conversion, especially for CMYK to CMYK. We discussed that over lunch. For RGB to CMYK, if I want to keep my pure red, for example, I can make sure that it's only using magenta and yellow in my conversion. Not necessarily 100%, but I can make sure that this is happening and not some cyan or some black coming in there. That can be done inside a device link, and therefore it makes for a better rendering, cleaner colors basically, and without getting this desaturation, what is very typical from the RGB to CMYK conversion. Another thing is transparencies. Transparencies are a nice tool for designers, no doubt, but if you have, for example, a compatible viewer, you'll see, for example, these are again, working with transparency check files. So this is a compatible viewer that shows the transparencies correctly. This is what you get on many other viewers, I have to say, PDF viewers, that are not handling those transparencies correctly, and then you see those X in those areas. So it's a nice tool to check if your viewer is compatible and can show transparencies correctly. Very often you will have those things, especially on the handheld devices. The other thing is if you're doing color conversion on PDF files, because you are converting to a CMYK and then you are repurposing to your final CMYK, basically. You're doing a CMYK to CMYK color conversion with a PDF document with transparencies. Keep in mind that you probably need flattening to render a transparency effect correctly. Otherwise, you might end up with those things. For example, here there is a hard line to be seen where this transparency effect starts to make this image lighter, for example. If this is color converted wrongly, basically, or independently without flattening, you might end up with those things. But as well, flattening tools, as Stefan was saying, can have an impact on results and have unequal results as well. So flattening is a little bit of a necessary but as well dangerous thing to do very often. And the thing which I'm very angry about, to be honest, is we're having this nice handheld devices. Leonard in his keynote was talking about 60% of the US people have a tablet today. But
I don't trust that number, by the way.
Let's say 50, but it's a large number.
It's probably closer to 25. That's still large.
Yeah, it's a large amount. So people are used to get their PDF files and view them on screen. However, if the two major applications there, iOS from Apple, Android, do not support ICC color management, only Windows RT does, then that's a big problem. The other thing is that those devices are very bright. They are tuned to have nice colors, basically. And this Flemish graphic organization, the VIC, has done a very nice test by putting different tablets on a paper, on a table, yeah, and produced the same image on each of them and made a photograph. So this is a relative comparison of different tablets that you see there. Yeah, so the colors of this image, of the same image, is rendered completely different without color management, depending on if it's very light color, if it's a very bright color or not. So the iPads, for example, those two, iPad 3 and 1, they're completely different. The Asus is completely different. The Kindle Fire or the Samsung or the Nook, completely different.
Well, what was that being displayed with on those? Were those PDFs or just TIFF images or something?
Yeah, I think they are just TIFF images.
Okay.
Just TIFF images. Just taking the typical render application.
The default that would render that image.
Exactly. So the default rendering, so not even CMYK, just RGB.
Yeah.
It's a very simple test, and it renders really, really bad. So
would it help to put these tablets in a viewing box?
No, not really. Not really. Unfortunately not. So there is a lot to do from the vendor side to improve the color management, to at least allow for the ICC color management to render the images correctly. And there is this other thing, overprints, transparencies, font issues on those PDF viewers, which make them useless basically for color reference at this point of view. So there is a lot of things to be done, perhaps even from our community where we have developers in there, at least doing something for their own applications. Yeah, today the only solution is to have his own ecosystem where you can support color management. Yeah, but on an OS level, it would be much better to have support directly from those systems. And this is basically really annoying me because it's like before we had the color management, before we had the ICC color management. So haven't we learned something, or haven't those companies learned something? So I'm really, really pissed by this. But I don't want to leave you with this very sad thoughts. But give you a good, bright view, basically, for better prints. So tag your images with the appropriate ICC profiles using the PDFX methodologies with the output intent for targeted print production. Create ICC profiles for all your paper, ink, printer combinations. Color convert to this target color space you want to print to, and using device links for CMYK to CMYK, and then you get much, much better prints than today. That's my final words.
Thank you.
There's a question over there?
Yeah, I understand that it's very important, especially the CMYK conversion when you go print and make print plates.
Mm-hmm.
How much of that is taken care of in the huge digital printers? You know, the Indigos and stuff like that.
Mm-hmm.
Is that automatically done in there when you say
No.
this paper, this ink?
Unfortunately not, no. So
Okay.
there very often there is a secret source, something that is happening there, and that's either you get pleasing colors, like what Peter was saying in his presentation. You get probably pleasing colors in a certain way, but if your goal is to print the yellow pages faithfully, you get a pleasing yellow which has nothing to do with the yellow of your original. So no, unfortunately not. No.
If I can answer part of that, in our experience at Adobe, when you go to conventional printing, separations, plates, whatever, you know, device CMYK is device CMYK is handed down from Mount Sinai, you know, you have 100% yellow, that's the colorant that you get. For the digital devices, I know of no manufacturer who has a don't fuck with me mode to device CMYK. They're all adding value to it, secret sourcing the thing. So effectively, you know, a lot of it's trial and error. It's really sad.
And building up knowledge.
Yeah, that's as well.
And each time you do that, that's more clicks before you get something that's worth
Doesn't
anything.
it automatically increase the threshold for traditional printers? I mean, okay, black and white print shops to go digital. I hear a lot about going white paper factory, you know, in transactional printing. What you're telling me is frightening, because all of a sudden you need to change a lot of the operators and make them color aware.
Absolutely.
Yeah.
No, I think it's not frightening. It should give you an idea that there is more to be done. So to really take advantage of your new Indigo, whatever kind of machine that has this wonderful, great gamut, but if you don't use that correctly, you'll end up with this example that I had there with this very oversaturated colors of the faces and completely wrong contrast and such things. If you handle it in a normal ICC color management way, everything will be fine. You know? The only thing is, if it's a CMYK device, CMYK to CMYK, then device links make for better prints, that's for sure.
You do have to get profiles for the particular devices, and they're not, most often not standard printing conditions. Some of these devices have emulation modes for progress, swap, you name whatever it happens to be, and they'll convert it to whatever their internal thing is. But the world of color management is very different for digital devices, not because it has to be, but because that's part of the product differentiation. It's part of the history and marketing more than it is the technology.
Perhaps one thing is, even if there is a good mode, for example, for this simulation of swap or iso-coated, this simulation works if the right paper is put into the printer, the right settings of that printer are defined. For example, the resolution might be as well having an impact on the color rendering. So basically, that's my point here, is the paper, the ink, and the printer settings have a big impact on how colors will be rendered. So you want to make sure that those are fixed, and if you can make sure that's fixed, and this secret source solution might be giving you what you expect, then you should stick to that. Yeah? But mostly it will not. Mostly it will not. And especially if you want to emulate something else, sometimes you want to emulate perhaps how a newspaper looks like, or want to do something else, what's a very common use case is for large houses like IKEA or something. They want to print on different kind of processes, digital, offset, graver, and it should all look the same and not different on this and different on this. Obviously the newspaper will look different than the offset, but you can have at least a similar appearance, and that requires a good color management. There's no way about it.
Could you go back to that slide where you had... yeah, exactly. First question one, is this a specific picture which shows these differences? Is this a randomly picked picture, do you think?
Yes, it is a randomly picked picture.
The other question is this a very specialized approach because you're a color specialist? How many people would really be, how do you say that?
Why they care about, would they care about it?
Yeah, or offended by the difference?
This is
or
where,
no?
this is where the problem comes in.
Yeah.
Okay,
I
it
agree.
started this morning with the discussion. You know, if 90% of the people who look at this stuff couldn't give a rat's ass about it and don't care about it, okay, the people selling the tablets are selling to the mass market. They're not selling to people who care about this stuff. The people who actually care about it, if you're a mass merchandiser, let's say, I at least know in the United States, if you're LL Bean or Land's End or Target or some company that's selling fashion, you have any idea how much merchandise is returned because it's the wrong color? And the wrong color is determined not from print ads, but from this sort of thing.
Very good.
And then it's not only PDF, it's browsers that don't support color management
No.
at all.
No, no.
And it is a real problem, but ironically what happens is the companies that should be worried about this, when they're approached either by Adobe in terms of what we support or by the tablet makers, they worry about, oh, how can we differentiate, how can we get our little button on the first screen that the user sees, as opposed to the technical issues such as color management. They don't bring up color management as something that's important to them, but it actually affects their bottom line.
So if you have this kind of environment, there is, from a color management point of view, you cannot do very much. You can make sure, for example, that your high saturated images are converted to sRGB to have at least a minimum common denominator, let's say, but still you have that different rendering. Yeah? So the same conversion of that sRGB image will be rendered differently on those devices then at the end. Yeah?
Yeah, but it's even worse, not only the end consumer looking at these devices and then comparing color. It's approvers of printed product for large number of copies which take their iPad and approve the color
Yeah.
on their iPad.
Yeah,
But
that's
at
much.
least that's a smaller controllable amount. You can tell them that, and hopefully they at least have some understanding what's going on. But typical consumers, color management, what's that? You know, it's your fault that the item isn't the same color as what they saw on the screen, and you have to go along with them because they're right. It isn't the same color.
I totally agree. You have a very good point, because you put a number to that error, which is the returns.
Yeah.
That's a huge problem.
But the
Yeah.
problem is that typically isn't associated with what's going out through the advertising or the type of device or anything like that. It's totally divorced from that. That's an operational problem. That's your shipping department. Oh, it must be an error in shipping or whatever. It typically does not isn't classified to the workflow in viewing the catalog contents on the screen and what sort of viewer and stuff like that. It's totally divorced, and that's what's rather unfortunate about this.
Well, when you return it and you say it's wrong color, most of the time you have to give a reason, right? Shouldn't that
But you're
pop
gonna
up?
say the RGB values don't match?
No,
you know?
no.
What's that now?
You would say that, but probably there is a tick in the box like wrong color, right?
You're wrong color, so how's that gonna be taken? Oh, they took the wrong color out of the bin. Oh, the person doesn't know what they really want.
Okay.
You
So
know,
they
it
interpret
doesn't
it.
get associated with, there's a mismatch between what was, I was talking to one retailer just last week about this sort of issue, and they're talking about these photographers sitting up with the lights and measuring the color temperatures and whatever, and it all gets screwed up at this end here. No matter what they do up front there, and no matter what they print in the Sunday newspaper, at least in the United States it's a Sunday newspaper, and these supplements on newsprint yet, and they get it really nice. If somebody's ordering it from an online web browser,
So you trust the newspaper more than the browser?
actually,
Yes.
yes.
One has to say yes, indeed.
Yes, that's what's so sad about this. And the thing is that no one correlates the financial losses of this thing to that. You know, it's sort of considered a noise, but if one was to actually be able to tally this up, I think it would be quite considerable. And again, it has to do with priorities, and the overall issue of color is, when is color good enough?
Yeah.
Okay, one could talk about a separate issue of one
Sure.
producing PowerPoint slides, and you want those bright blues and the bright reds and the bright greens and things like that. And if you want to print those,
Then you come here, no, and then you come here.
Yeah, but
And they look terrible on
Yeah.
these devices.
Yes.
well, they look better on the screen, they look lousy here, they many times look even lousier on print. And the thing is, you can produce things that are colorimetrically correct based on assumptions about the RGB on the screen. They may be 100% colorimetrically correct, but they're 100% wrong because the user's perception of what the blue is supposed to look like in a PowerPoint presentation. So color is very subjective, and that's a whole other thing we're not discussing today, but that's some of the reasons why my hair has gotten changed colors and disappeared over the year. But that opposite sort of thing, for an opposite sort of thing, which is basically you have great color on the screen, you're doing things right, but that's not what they want. So, color, and anyone who thinks they've solved color completely, don't trust them. Don't trust them at all.
No. For printing, we are used, that's perhaps a statement here, for printing, the vendors, for example, like Coca-Cola, they impose very strict rules how, for example, their red should be printed on those digital devices. I think this needs to come over time, and people, those companies need to learn to have as well some rules there. But of course, the technology must work. Otherwise, there is no possibility to change that accordingly. And that's something to have to be happen, I think, I hope.